Today's topic, it's a continuation of last topic. It's called algebraic multiplications, but we are focusing today on polynomials. So the first thing we need to know is that if we multiply two polynomials, we will need to multiply every term on one parenthesis with every term on the other parenthesis. So that's going to be the important part. Every term of the first parenthesis will be multiplied for every term on the second parenthesis. We will, after multiply, we will need to look or to use like term simplification. Remember, like terms are those that have the same letters and powers. So we will do like term simplification if possible. And at the end, we will need to order our answers with the rules of criteria for this specific course. The first topic that we are going to see today is how to multiply two binomials. It is also called the FOIL method when multiplying two binomials. We will see why it's called the FOIL method. So in this case, if you see here on the bottom part, you will see a little cage with the word FOIL. There will be why the name FOIL method, because as the rule says, when we multiply two binomials or two polynomials, we will need to multiply every one of the terms in the first parenthesis for or with every term in the second parenthesis. So in this case, it says FOIL method, like to make an mnemotechnic word that will help us to remember how to multiply it. In this case, is first terms, it will be x multiplied by x. It will be outer terms, x multiplied by minus 3, x multiplied by minus 3. It will be inside terms, so in this case 5 multiplied by x. And finally last terms, that it will be 5 multiplied by minus 3. So in this case, if we multiply all of this, we will get x squared minus 3x plus 5x minus 15. We can do like term simplification with these ones. 5x minus 3x, it's only 2x. So our final and ordered answer will be x squared plus 2x minus 15. And that will be our multiplication of those two binomials. So that's why it's called the FOIL method. Remember, FOIL, it's meaning it's first term, outer terms, inside terms, and last terms. So that can be a word to help us remember that it's the first or the first parenthesis terms multiplied by every second parenthesis terms. So let's see some other examples today. So in the next exercise in FOIL method, we will use this multiplication of two binomials. So remember the rule, it says to us, first terms, it will be 5x multiplied by 2x. Then outer terms, it will be 5 multiplied also by 3. So 5x multiplied by 3. Then it will be inside terms, minus 7 multiplied by 2x. And finally, outer or last terms, last terms, it will be minus 7 times 3. So in this case, we will get 5 times 2 is 10. X and x multiplied will be x squared. 5x multiplied by 3, it will be 15x. Minus 7 multiplied by 2, it will be minus 14x. Then we will have minus 7 multiplied by 3, it will be minus 21. These two of them are common terms or like terms. They are like terms, so we can simplify them. It will be minus x. So in this case, the ordered answer will be 10x squared minus x minus 21. So this is a very simple way or method to do two binomial multiplication. So in this case, every time that we have two binomials, we can use the FOIL method. Remember, first terms, outer terms, inside terms, and last terms. Let's see some other example of FOIL method. So in the next exercise, we have something like this. It's two binomials, so we can use the FOIL method. Remember, the FOIL method will be first terms, that will be 7x to the n minus 1 multiplied by 2x cubed. Then it will be outer terms, so it will be 7x to the n minus 1 multiplied by minus 3. Then it will be inner terms or inside terms, that it will be 5 multiplied by 2x cubed. And finally, last terms, that it will be 5 multiplied by minus 3. So in this case, we will get, with the first one, we are going to get 7 times 2, it's 14. The letter is x. And in this case, we will get n minus 1 plus 3. So it will be 14x to the n plus 2. Then in the second term, we will get 7 times minus 3, it's minus 21x and minus 1. The next one is going to be 5 times 2, it's 10x x cubed, and the final term, it will be 5 times minus 3 minus 15. So in this case, we don't have like terms, so we cannot make like term simplification. So in this case, we are going to put this in alphabetical order. In this case, because we don't know exactly the value of n, we cannot know if it's a bigger x to the n plus 2 or 10x cubed. So we are putting first the one that has only the power of x first, then the ones that have a variable. So in this case, we can put it like 10x cubed plus 14x to the n plus 2 minus 21x to the n minus 1 minus 15. And that will be our final unordered answer. So let's see another type of exercises, that it's where we are multiplying two polynomials. So when we have an exercise with two polynomials, we cannot use the FOIL method because there are more than one inner and or inside terms that are we cannot use the FOIL method. So in this case, we will need to follow the other rules that are the same. They are exactly the same, because what will happen is that we are going to use all the terms in the first parenthesis, and they will multiply all the terms on the second parenthesis. So let's see. The first term that we have, 5x, will multiply the first term, the second term, and the third term of the second parenthesis. So in this case, you can do all the multiplications by mind, but you can also put them, that's your decision. I'm going to make them by mind. In this case, 5x cubed multiplied by 4x squared. So it will be 5 times 4, it's 20. X cubed and x squared, it will be x to the 5th. Then the next one is going to be minus 8x multiplied by 5x cubed. So minus 8 multiplied by 5, it's minus 40. X is x cubed and x to the 1, it will be x to the 4. The next one is going to be 5 times minus 6, it's 30 x cubed. Then we will use the other term, the second term, multiplied by the 3 terms or all the terms in the other parentheses. So in this case, it's going to be minus 3 multiplied by 4, minus 12 x squared, and x squared is x to the 4th. This next one is going to be minus 3 multiplied by minus 8. It will be minus multiplied by minus. Remember, that will be a positive one. Minus 3 times minus 8, it's going to be plus 24. X squared and x1, it's going to be x cubed. And finally, minus 6 multiplied by minus 3, it's also positive, 18x squared. Finally, we will do the same with the last term. It will multiply all the terms in the other parentheses, so it will be 7 times 4, it's 28x squared. 7 times minus 8, it will be minus 56x minus 7 times 6, 42. Then we need to do like term simplification and ordering. So we are going to start with the bigger powers in the ascending order of powers. So in this case, the bigger one, it's the one that has x to the 5th. It doesn't have anything to add or subtract, so it will be 20x to the 5th. Then we will look for x to the 4th. We have minus 40 and minus 12. It will be minus 52 x to the 4th. The next one, it will be x cubed. Minus 30 plus 24, it's going to be minus 6 x cubed. Then we are going to do the same with x squared. In this case, 18 plus 28, it's going to be 46 x squared, positive one. Then we will look for x that doesn't have anything to add, also the number that doesn't have the independent term, nothing to be summed or subtracted. So this is going to be our final unordered answer. So remember, the process is going to be very simple. We are going to multiply every term in the first parenthesis with every term on the second parenthesis. After we do that multiplication, we will look for like term simplification and ordering your answer. So there are like 3 simple steps. Multiply every term by every term, then use like term simplification if possible, and at the end, remember to order your answers. So let's see some other example. So in the next exercise, we are going to do the same. We got a multiplication between 2 polynomials. In this case, we cannot use the FOIL methods as we saw, but we can multiply every term on the first parenthesis with every term in the second parenthesis, then use like term simplification and ordering our answer. So let's see. First, we will need to multiply the first term with the 3 terms on the other parenthesis. So it will be something like this. Remember, for multiplying fractions, we multiplied the top part and the bottom part. So it will be 5 times 3, it's 15 over 6 x squared. You can also do the simplification of the fractions first and then multiply. It's up to you. I will do in this case first the multiplication, then the simplification. So the second one is going to be minus 8 times 5, it's 40 ninths of xy minus 35 15ths of xc. Then we can do the same with the second term. So it will be this term multiplied by the first one, then by the second one, and finally by the third one. So let's see. The first one is going to be minus 6 over 10 xy. Remember to put it in order because we can put it like yx, but we need to use alphabetical order. So the second one is going to be minus multiplied by minus, it will be plus. 8 multiplied by 2, it's 16. 3 multiplied by 5, it's going to be 15 y squared. Then we will put, in this case, minus multiplied by minus, it will be plus. It will be 7 times 2, 14 25ths of yc. And finally, we're doing the same with the third term, multiplying by the first one, multiplied by the second one, and also multiplied by the third one. So it will be plus 3/4 of xz. It will be minus 8 over 6 yz. And finally, minus, it will be 7/10 of z squared. Then after we do this multiplication, we can simplify our fractions, or we can first make the like term simplification, and at the final step, like simplifying the fractions, it's up to you. I will simplify this fraction, so in this case we can get divided by 3, and it will be 5 over 2 x squared. The next one we cannot get simplified in this case, so it will be minus 40 over 9 xy. The next one we can simplify it and divide it by 5, so it will be 7/3 of xz. The next one is going to be divided by 2, so it will be 3/5 of xy. The next one, it cannot get simplified, so it will stay the same. The next one, it cannot get simplified, so it will stay the same. The next one cannot get simplified, 3/4 of xz. And the next one can get simplified, can get divided by 2, 4/3 of yz. And the last one we cannot simplify it, so it will be something like this. In this case, we will need to look for those that are like terms in order we can add them or subtract them. So in this case, we have xy, and we have xy, we have xz, we have xz, we have yz, and we have yz. So in this case, we will need to add xy. In this case, the least common denominator between the two of them, it's 45. All the two of them are negative ones, so we can make the conversion. The first fraction, it's going to be multiplied by 5, so 40 multiplied by 5, it's 200. And the second one gets multiplied by 9, so it will be minus 27. So we will get minus 227 over 45 xy. This one is a fraction that we cannot simplify, so it will stay like that. So the next one is between xz, and we have 3 and 4 as denominator, so the least common denominator is going to be 12. So we will change it to 12 xz, xz. The second one is a positive one. So this one, the first one, we need to multiply it by 4. So it will be 28 over 12. The second one gets multiplied by 3. So it will be 9. So in this case, we will obtain minus 19 over 12 xz. And finally, we will do the same with yz. We have as denominator 3 and denominator 25. So our common denominator between 25 and 3 is going to be 75 yz. The first one, it's positive 1. The second one, it's a negative 1. So the first one, it's multiplied by 3. So we will multiply it by 3. 14 times 3. 42. So it will be 42 over 75. The second one gets multiplied by 25. So 25 multiplied by 4, it's 100. So we will get a negative 1 because the negative 1 is bigger over 75 yz. It will be minus 58. We will need to see if 58 over 75 it's a simplifiable fraction. In this case, it's not a simplifiable one. So then we will need to put this in alphabetical order or descending order of powers. We need to put our answer in order. So in this case, we need to start with letter x, that is the first one, and x squared, it's the bigger one. So it will be our answer 5 halves of x squared. Then we will put minus 227 over 45 xy minus 19 twelfths of xz. Then we will put the ones that have y only, then y and z. So it will be plus 16 fifteenths of y squared minus 58 over 75 yz, and finally z squared. And this is going to be our final and ordered answer. So this one I made, it's very tricky one. It's very not confusing, but it's a long exercise. So please, maybe you can copy it in your notebook, because something like this can be on an exam, so it's very important for you to know it. We will see another example. So in the next exercise, it's a trinomial with a binomial. I only wanted to put something like this because it doesn't matter what types of polynomials we have. We can have binomial and polynomial, trinomial and trinomial, polynomial and trinomial. Each like combination, it's made the same. So in this case, the first one will multiply all the terms in the second parenthesis. So it will be 3 times 2, it's 6 x to the fourth, plus 3 multiplied by 8, 24 x squared. Then it will be the same with the second one, multiplying all the terms in the second parenthesis. So it will be plus 10x cubed, then plus 8 times 5, it's 40x. Then it will be the last term multiplying all the terms in the second parenthesis. So it will be minus 6x squared minus 24. So then we are going to use like term simplification and ordering. So in this case, the bigger one, it's 6x to the fourth. So it will be 6x to the fourth. Or to next, we are going to look for x cubed plus 10x cubed. Then we are going to use x squared. So in this case, it's going to be plus 18 x squared plus 40x minus 24. And this is going to be our final and ordered answer. So the steps are simple. I don't need to make other exercises, but the steps are simple. First, multiply every term of the first parenthesis by all the terms in the second parenthesis. Then use like term simplification and use ordering for your answer. So it's a very simple topic, but it's a very long one. So please start doing your activity for today. Thank you, and it's a pleasure always to explain these topics to you.